I would like to comment that probably the biggest issue with regard to sewers clogging is fats, oils, and grease, and improper disposal of grease using a disposer is a behavioral and educational issue that we try and discourage through our instruction, care, and use manuals. Certainly, it's not appropriate to put grease down any sink or disposer or even a toilet. I'm always amazed when I talk to young kids and they say, "Oh, we never pour grease down the sink. We pour it down the toilet." You know, free fats and oils that are disposed of by way of the sewer are going to cause a problem, and so that's an area of active research that we're involved with as well.
You use the figure of 30 million tons produced annually. I think that's an EPA figure. At 50% market penetration, are we talking about 15 million tons of additional suspended solids in the wastewater treatment collection system?
Yeah, I think when I listed those statistics, my intention was not to say that we should divert all 30 million tons. If we look at waste management holistically, obviously you're going to have to use landfills. In some cases you'll be using incineration. In some cases you'll be using composting. If you extrapolate data now on the fact that only about 50 to 75% of food waste from a kitchen is actually used or actually goes down through a disposer, about 7 million tons of food waste probably goes to treatment plants instead of going to landfills. So that would be current. Whether or not we can divert the other 23 million tons, that would be a significant impact on treatment plants. There's going to be some treatment plants that are overloaded organically and maybe not be able to handle that, either through their sewers or maybe not have adequate organic capacity. But certainly many plants are underloaded, and it's always more difficult to run a treatment plant that's underloaded organically than it is overloaded.
In the example that you used in, I think it was Sweden, that they have a plant there with a net positive energy generation. Do you have any idea what their loading ratio is relative to, say, one that is not operating on a primary anaerobic digester?
I'm not sure I understand the question. They do have anaerobic digestion. Versus one that does not have anaerobic digestion? Yeah, obviously if there's no anaerobic digestion, you're not getting as much of a benefit. We're actually developing a spreadsheet where we can look at different communities where you can look at the different levels, whether you have primary treatment only, secondary treatment, whether you have aerobic digestion or anaerobic digestion, whether you beneficially reuse the biosolids or not. There's so many different variations that you have to look at the specific location to find out what benefit is actually gained. But certainly with reduced phosphorus availability, and the fact that maybe within 20 years we will no longer be able to mine phosphorus, the beneficial reuse of biosolids is a good thing whether or not you have anaerobic digestion or not. So even with aerobic digestion, the beneficial reuse of those biosolids is something that communities
That's just a 5-minute warning bell for everybody for the first session. Thank you.
We might be mining phosphorus from landfills someday down the road. In landfills? There's a lot of new technology being developed in Germany to extract phosphorus from wastewater streams as well.
Do you have any information on post-digestive composting? For example, many plants will take the wastewater treatment sludge from the aeration basins and clarifier basins and the leftover sludge from the primary anaerobic digester and mix it with other organic compounds such as yard wastes and trees, leaves, agricultural waste, and so on, composting it into a soil amendment. Do you have any statistics on the beneficial use or beneficial result of that process?
I actually worked at a facility in Elkhart, Indiana that composted yard waste along with their biosolids. And they did that so that they could meet Class A status, EPA biosolid standards. By composting those things together, they create a product that's more friendly for residential use, gardening, as well as landscaping. It is popular. You know, when you have the right mixture of compost materials and you create those higher temperatures, you get better pathogen kills. In Elkhart, we actually met Class A requirements coming out of the belt filter presses from the digesters. but then by composting it, we got an even better product, even lower in pathogens. So certainly there are a number of communities that are composting their biosolids together, and by sending the food waste first to the treatment plant, you get the added benefit of the biologic nutrient removal as well as solids reduction. 40 to 60% of your solids are reduced by anaerobically digesting them first before you would composting. So certainly nothing wrong with composting biosolids together.
In your investigation of the transport side of the food waste solids, do you have any information on lift station loading and other issues regarding increasing the suspended solid load in the effluent flow?
I think Chamanaglis lists about a 20% increase in suspended solids and BOD from the use of disposers. Like I said, that sounds significant, but when you consider typical treatment plant loadings are about 200 milligram per liter BOD suspended solids, it's not a huge amount compared to the overall loading of a plant. And having operated probably a half a dozen plants in my 17 years, it's very difficult to run a plant that's underloaded organically. If you have more organic waste, you simply increase your wasting. You produce more biosolids. When you're underloaded, keeping that microbiological system happy is difficult because you can promote filamentous bacteria. You can run into situations where you have Nocardia bacteria that are very difficult to eliminate from a treatment process. So from that standpoint, additional loading in a treatment plant is not an issue. Probably one of the unresearched areas would be hydrogen sulfide production. That's usually associated with increased organic loading on sewers. It's very important to have adequate velocities and not very long detention times anywhere in a collection system, including your lift stations that you alluded to. So that could be an issue. If you have a long distance to travel, long detention times, especially in a lift station, you could have some hydrogen sulfide issues. But that's without saying whether you have food waste or not.